Electromagnetic theory. Electromagnetic theory is one of the most important topic for IIT, JAM, MSc entrance, Csir Net Gate. First, we know the difference between electrostatics, magnetostatics, and radiation. When charge Q is at rest, then magnetic field is zero. Only electrostatic field is present. So we can call it as a electrostatics. In electrostatics, there is magnetic field zero and charge is at rest. So we can call it as electrostatics. In magnetostatics, charge is moving and the velocity is constant. Charge is moving with a constant velocity, that is uniform charge. The motion of the charge is uniform, so the magnetic field is produced. So we can call it as a magnetostatics. In a radiation, charge is moving, but the velocity of the charge is not constant. It is accelerating continuously. It is like electromagnetic waves. The velocity is not constant in electromagnetic waves, so we can call it as a radiation. First, electrostatics. We study first electrostatic, and electrostatics is only when charge is at rest. That is Coulomb's law and Gauss law are in electrostatics. Let's study about Coulomb's law. Coulomb's law is applicable to point charges only. When there is point charges, we can apply Coulomb's law. Let us consider 2 point charges. Q1 and Q2, and the distance between them is r, small r. We know that the force is directly proportional to the magnitude of charges, that is F is directly proportional to Q1 and Q2, and the electrostatics force between these two charges is inversely proportional to the square of the distance between them. By combining 1 and 2, we can write it as F is directly proportional to Q1 Q2 upon R square, or F bar is equal to K into Q1 Q2 upon R square. K is 1 upon 4 pi epsilon. It is a constant and its value is 1 upon 4 pi epsilon. So we can write it as F bar is equal to 1 upon 4 pi epsilon Q1 Q2 upon R square. This is Coulomb's law. We know that epsilon is equal to epsilon naught into epsilon r. That is for air medium, epsilon is epsilon naught. That is epsilon is equal to epsilon naught. F bar air is equal to 1 upon 4 pi epsilon naught Q1 Q2 upon R square R cap. This is the Coulomb's law for air medium. It is epsilon R is equal to is relative permeability or permittivity. It is relative permittivity. F bar for medium is equal to F bar for air upon epsilon r. This is the formula for how to apply Coulomb's law. There are two types of charges. Like charges and unlike charges. Like charges repel each other. That is like positive positive, negative negative charges repel each other and the direction of the force is the away from the charge. Unlike charges attract each other and the direction of the force is the towards the charge. First, we find the net force on the charge due to like charges. We consider the two like charges plus Q1 and plus Q2. And the distance between them is r. First, we have to find the net force on the charge Q1 due to charge Q2. The both charges are the like charges, therefore they repels each other.
and the direction of the force is away from the charge Q2. Let's see here, the direction of the force is away from the charge Q2. For that we draw the line on the charge Q1 and we draw the direction is away from the charge Q2 and the force F12, the force on the charge 1 due to charge 2, that is F12 is equal to K Q1 Q2 R square, and the direction is R21 from the charge 2 to charge 1, that is R21. Let's find the force on the charge Q2 due to the charge Q1. Both charges like, therefore they repels, and the direction is away from the charge. The direction is away from the charge Q1, that is F, and the net force on charge Q2 is F21 is equal to K Q1 Q2 upon R square, and the unit vector is R 1 2. The direction of the force is from 1 to 2, and the R cap 2 1 and R 1 2 are in a opposite direction. We can see in diagram the direction of this 2 is opposite, that is R12 is minus R21. Yes, we consider this line is a 0 and the left hand side is negative and the right hand side is positive, that is R12 is a positive and R21 is negative, that is similarly F12 is equal to minus F21. The charges have the same, or the force have the same magnitude but the opposite directions. Similarly, we can find the net force due to unlike charges. That is, we have two charges plus Q1 and minus Q2. And we have to find the net force on charge Q1 due to the charge minus Q2, and the distance between them is R. Let's first find the charge or force on charge Q1 due to the minus charge Q2. The both charges are opposite, therefore they attract each other and the direction is towards the charge, therefore the direction is towards charge minus Q2, and the net force F12 is equal to K Q1 Q2 R square R12. The net force on the charge minus Q2, they both charges are opposite, therefore they attract each other and the direction is towards charge Q1. That is, force on the charge Q2 is F21 is equal to K Q1 Q2 R square, and the unit vector's direction is R21. When we have to consider the charge on the unit vector, we have to draw the line on this charge and we have to draw the directions. When directions is the left hand side, it is negative, and when direction is the right hand side, its sign is positive. That is, R cap 1 2 is equal to minus R cap 2 1. That is, F12 is equal to minus F21. And while solving the problem, don't take a negative signs, only take its magnitude. It is first example. Find the net forces on the charge Q1, Q2 and Q3. we have three charges, plus Q1, minus Q2 and plus Q3. And the distance between charge plus Q1 and minus Q2 is R1, and minus Q2 and plus Q3 is R2. Let's first find the net force on the charge Q1 due to charge minus Q2. The both charges are opposite, therefore they attract each other, and the direction is towards the charge minus Q2. That is F2 is equal to K Q1 Q2 upon R1 square, and the net force on charge Q1 due to charge Q3, both charges are positive, therefore they repels each other, and the direction is away from the charge. That is F3 is K Q1 Q3 upon R square, this is I cap and this is minus I cap. The direction is from left hand side and right hand side. The net force on the F1 is equal to K Q1 Q2 R1 square I cap minus K Q1 Q3 R square I cap. This is the net force on charge Q1 due to charge minus Q2 and plus Q3. F1 is equal to K Q1 Q2 upon R1 square minus K Q1 Q3 upon R square, bracket complete, I cap. This is the net force on charge Q1 due to the charge Q2 and Q3. Net force on charge minus Q2 due to charge plus Q1 and plus Q3. We have three charges, plus Q1, minus Q2, plus Q3. And the distance between the charge plus Q1 and minus Q2 is R1. The distance between charge minus Q2 and Q3 is R2. And the distance between plus Q1 and plus Q3 is R. So we have to find the net force on charge minus Q2 due to the charge plus Q1, and the both charges are opposite, therefore they attract each other, and the direction of the net force is towards the charge Q1. That is F1 bar is equal to K Q1 Q2 upon R1 square. This is in left hand side, therefore the minus I1 cap. This is the unit vector, and the net force on the charge Q2 due to the charge Q3, this is in the direction of the Q3, the unit vector in the direction Q3, that is I cap.
F3 is equal to K Q2 Q3 upon R2 square I cap. This is in right hand side of this polarity. Therefore, it is plus I cap. The net force F2 is equal to, in bracket, K Q2 Q3 upon R2 square minus K Q1 Q2 upon R1 square I cap. This is the net force on the charge minus Q2 due to the charge plus Q1 and plus Q3. Force on charge plus Q3 due to the charge plus Q1 and minus Q2. So we have three charges, plus Q1, minus Q2 and plus Q3. The distance between plus Q1 and minus Q2 is R1. The distance between minus Q2 and plus Q3 is R2. And the distance between plus Q1 and plus Q3 is R. So we have to find the net force on the charge Q3 due to the charge minus Q2. Polarity is opposite, therefore attracts each other, and the direction is towards the charge. It is F2 is K Q2 Q3 upon R2 square. The net force on the charge Q3 due to the charge plus Q1, both have same polarity. That's why it repels each other and the direction is away from the charge Q1. And the F1 bar is equal to K Q3 Q1 upon R square. F3 is equal to K Q3 Q1 upon R square minus, this is plus, this is minus I cap, minus K Q2 Q3 upon R2 square into I cap. F3 is equal to K Q3 Q1 upon R square minus K Q2 Q3 upon R2 square I cap. Example, next example, find the force on the minus Q by 2 charge we have charges plus Q, minus Q by 2 and plus Q, and we have to find the net force on the charge minus Q by 2 due to the charge plus Q and plus Q. The distance between them is D and distance between them is G. So we draw, this is charge 1, this is charge 2. The net force on the charge minus Q by 2 due to the first charge. Both charges have opposite polarity, that's why they attract each other, and the direction of the force is towards the charge. That is F1 bar is equal to K Q by 2. We have to take only magnitude, not take this sign. k q by 2 q upon d square is equal to k into q square by 2 upon d square. This is F1 and the direction is in right hand direction, therefore it is positive I cap. The force on minus q by 2 due to the charge second, that is plus q, and both charges have opposite polarity, that's why they attract each other, and the direction is towards the charge plus q, and it is in a left hand direction, therefore its sign is negative of unit vector I cap. It is F2 is k q square by 2 upon d square minus I cap. The net force F minus q by 2 is equal to k q square by 2 upon d square minus this k q square by 2 upon d square I cap. This is same quantity, it becomes 0 I cap, that is F minus q by 2 is equal to 0. That is the net force on the charge minus q by 2 due to these two charges plus q, and plus q is 0. Example number 3. Find the net force on the minus q. We have charges plus q, minus q, and plus q. And the distance between plus q and minus q is d by 2, and the minus q and plus q is d. We have to find the force on the charge minus q due to this first charge. Both charges have opposite polarity, that's why they attract each other, and the direction is towards the charge, and it is in a left hand direction, therefore it becomes some minus I. It is F1 bar is equal to k q square upon d square by 4, and F2 that is this both charges are in opposite polarity, the direction is towards the charge I cap. F2 bar is equal to k q square upon d square. F bar is equal to k q square upon d square minus 4 k q square upon t square, bracket complete I cap. This is the net force on minus q charge due to the plus q and another plus q charge. Next example. Example number 4. Find the net force on the q by 2. We have 3 charges, plus q, q by 2 and minus q by 2. The distance between q and q by 2 is d by 2, and q by 2 and minus q by 2 is d by 2. We have to find the net force on q by 2. We draw the line on q by 2. This is charge 1, 2 and 3. Due to the charge minus q by 2, both charges are opposite polarity, that's why they attract each other and direction is towards the charge. F3 bar is equal to k q square by 4 upon d square by 4 is equal to k q square upon d square. 4 get cancelled. This is the in right hand direction, therefore it becomes positive I cap. Due to the plus q charge, both charges are positive, therefore they repels each other and the F1 bar is equal to q square by 2 upon d square by 4 they repels, therefore this direction is again positive. It is again a right hand direction, so it is again